Good morning, guys. Now we will start our next lecture. So in this lecture we will solve another example which is based on the one-dimensional spring element. Okay, so we will try to find out the displacement and reactions value for this spring system. Okay, so we will start our next example. So like the example is like here it is given that there are two spring systems. Means spring system contains two springs with spring constant or stiffness K1 is equal to 100 Newton per meter and K2 is equal to 100 Newton per meter. Okay, and they have given at this last node there are three nodes, 1, 2 and 3. Okay, and at last node they have given one force, unknown force, which is to be determined F, and for this they have given the displacement of this node 3. It is given equal to 20 mm. 20 mm. Okay, so this spring system contains two springs with spring constant K1 is equal to 100 Newton per meter, K2 is equal to 100 Newton per meter, and the third node is displaced by amount delta is equal to 20 mm. Okay, and the question is that first find out displacement at node 2, and second is what? Find out the force value F and reaction. Okay, so this is the question. So first here find out the displacement, and second one is what? Find out the force value F. Okay, so now we will start this example. We will start on this. First one is what? Find out the displacement at node 2. This is very simple example. Actually this example is asked for 6 marks. Okay, in your INSEM exam. Okay, so such type of examples will be asked in your INSEM exams. Okay, so now we will try to find out the displacement at node 2, and we will try to find out the force value F and as well as the reaction R. Okay, so now the spring system contains 3 nodes, 1, 2 and 3 nodes. So first step is what? So first convert this real life problem into finite element problem. Means converting this real life problem into discrete problem by dividing this whole or entire domain into number of elements. So as there are two springs, means we need to consider here two elements. One spring has this spring has one element and second spring has second element. So there are two elements, 1 and 2. Okay, with spring constant K1 is equal to 100 Newton per meter, K2 is equal to 100 Newton per meter. Now second step was find out the elemental stiffness matrices. Okay, so first we need to find out the elemental stiffness matrices, then we need to construct the global stiffness matrix. Now global stiffness matrix, what is the order of that global stiffness matrix? What will be the order? What will be the order of that global stiffness matrix? So as there are 3 nodes, 1, 2 and 3, so the order of that global stiffness matrix will become 3 by 3. Okay, because as the number of nodes is equal to 3, so order will be 3 by 3. So global stiffness matrix K is of order 3 by 3. So first we need to construct elemental stiffness matrices for these two elements. Then by using these elemental stiffness matrices, we will construct our global stiffness matrix. Okay. Then third step is what? Or fourth step is what? Write this global stiffness matrix in your force and displacement relationship. Okay, means as we know that the force and displacement relationship equation it is given by F is equal to K times. So we need to write down this global stiffness matrix in this format. As there are 3 nodes or 3 by 3 matrix, so number of equations will be equal to 3. So by using this global stiffness matrix, we will write down this into the matrix format. Means you will get the 3 equations. Okay. Then next step is what? Apply the boundary conditions. First for nodal displacements and second for nodal forces. And then by elimination approach, we will get the final answer. Means answer for displacement and finally the force one. Okay. So now first we will construct the elemental stiffness matrix for 2 elements. So this is first element, this is second element. So elemental stiffness matrix E1. As we know that the basic formula for to construct the elemental stiffness matrix of the spring element is what? K minus K and okay. So by using this basic elemental stiffness matrix formula, we will construct our elemental stiffness matrix for this first element. As so instead of K, here the value of K is given as 100 Newton per meter. So it will become 100 minus 100 minus 100 and 100. Okay. So, but the position of this elemental stiffness matrix, actually this will lie, actually it is lying between node 1 and node 2. So its position will become 1, 2, 1. Okay. Similarly, now construct the elemental stiffness matrix for this second element. So this will become A2 is equal to. Okay, similar to the elemental stiffness matrix of this matrix, we will construct our second elemental stiffness matrix. As instead of K, here K2 is given as 100. So this is same as E1 and 100. Okay. So now here you will get the elemental stiffness matrices E1 as well as E2. Now third step is what? Now construct the global stiffness matrix by using these 2 elemental stiffness matrices. Actually the position of this E2, it is between node 2 and 3. Node 2 and node 3. Now construct the global stiffness matrix K as we know that its order is 3 by 3 because the number of nodes in the spring system is equal to 3. So its order will become 3 by 3. So finally it will become, it is very simple how to map or how to construct this global stiffness matrix by using this E1 and E2 as we have discussed these things in previous lectures. So now we will construct our global stiffness matrix. As we know that there are 3 rows and 3 columns. Okay, there should be 3 rows and 3 columns because this is 3 by 3 matrix. So now put this E1 into position between 1 and 2. Between 1 and 2. Because its position is between 1 and 1 and 1 and 2. Then E2 in between node 2 and 3 or between position 2 and 3. So it will be mapped here. Okay, between 2 and 3. Between 2 and 3. So similarly, write down the elements here. So for first, this is 100 minus 100 minus 100 100. So it will become 100 minus 100 minus 100 and 100. Then next, write down these elements over the position between 2 and 3. So here it will become plus 100 minus 100 minus 100 and 100. Okay, and the remaining elements will become equal to 0, 0. Okay, so in this way you will get the global stiffness matrix K as 100 minus 100 0 minus 100. This will become 200 minus 100 0 minus 100 100. So in this way you will get the global stiffness matrix as, so global stiffness matrix will become equal to K is equal to, finally you will get this global stiffness matrix. So 100 minus 100 0 0 100 plus 100 200 and this minus 100. then 0, minus 100 and 100. Okay, so in this way you will get the global stiffness matrix K. Now next step is what? Write down the force and displacement relationship. Okay, so how the force and displacement relationship is written? By using this formula. Force vector is equal to global stiffness matrix K times nodal displacement vector. Now we need to denote the nodal forces as well as nodal displacements over these nodes. Okay, so first, this is your first node. So for this, F1 is the nodal force and U1 is the nodal displacement. For second node, F2 is the nodal force and U2 is the nodal displacement. And for third node, F3 is the nodal force and U3 is the nodal displacement. Okay, so this stiffness matrix, now it can be written in this form as we know that LHS is your nodal force vector. So nodal force vector will become, as there are three nodes, 1, 2, 3. So it will become F1, F2 and F is equal to global stiffness matrix into nodal displacement vector U1, U2 and U3. U1, U2 and U3. So in this way you will get the force vector and displacement vector relationship. Okay, so this can be written it as like. Now next step is what? Next step is what? Apply the boundary conditions. Okay, so now we need to apply the boundary conditions. Okay, so by applying the boundary conditions, so how to apply the boundary conditions? First for nodal forces. Okay, so now for this first node, F1 is considered to be equal to reaction R1 and which is nothing but unknown value. So F1 it will become R1. Now F2, the value of F2 at this node it is not given as well as it is not fixed, it is free one. So the value of F2 is not given, so we will consider this F2 is equal to 0. As the value of F2 is not mentioned in this example, so we need to consider it is equal to 0. Now next is F3. So this is F3. Actually this is unknown and we need to find out this value. So F3 is not given. So this is actually here the question is what? Find out this value of F. So it is unknown. F3 will become unknown. Okay. So F3 it will become capital F. Actually this is the question. What we need to find out this value of F. Now next, this is about your nodal forces. Next step is what? Apply the boundary conditions for nodal displacement. Now for U1, as this U1 is fixed one. Okay. This first node is node 1 is fixed one. So at this node the displacement will become 0. Due to this fixed position, your displacement will become 0. So U1 will become 0. Now next, U2. The value of U2, this node U2 is not fixed as well as the U2 it will displace by some amount of this force F. So the value of U2 is unknown. We need to find out. Means U2 is your unknown value. Question mark. And third one is U3 at this node. But the value of U3 at this node, displacement value is given. This node is displaced by an amount delta is equal to 20 mm. Okay, so U3 is given. So U3 is given, it is equal to 20 mm. Okay, so in this way you will get first boundary condition for force vector and second is for your displacement vector. So in this way you will get final equation as R10F, R10F. Okay. This is for your force value. Second one is 0, U2 and 20. 0 U3 and 0 U2. This is first one is 0, U2 and 20. Okay. 0, U2 and 20. And here R1, 0 and F. Okay. So now, from these three equations, now we will find out the value for U2 as well as the forces F and reaction R1. So from these three equations, here at RHS, which value is known? For second equation, the value is known, equal to 0. First equation, LHS is unknown, as well as third equation, LHS is unknown, means this reaction R1 and F1 is unknown. So in this way, we will find out, or in this way, we will eliminate this first row, first column, because at LHS, your first equation value is unknown. So according to our rule, if the value is unknown for LHS, then we need to eliminate this row, first row and first column. Similarly, this is unknown also, F is also unknown. So eliminate third row and third column. Or you can apply the elimination approach in different ways. Means at RHS, those values are known for the displacements, eliminate those rows and columns. Means here, for this displacement row, we know the value for U1 as well as value of U2. So eliminate this row as well as column. Similarly, eliminate the known value row and column. Eliminate this third row and third column. So here, the second equation, now the remaining is the second equation. So this will become 0 is equal to, this is eliminated, right? So it will become, this is 0. 200 times U. 200 times U. Okay. So it will become 200 times U2. Then 200 times U. Now minus, this is eliminated one, but the value for this U3 is known and it is equal to 20. So minus 100 into 20. Minus 100 into 20. Okay. So first this equation will become 0 is equal to 0 into 0, 0. Means 0. Plus 200 into U. 200 into U. Minus 100 into 20. Minus 100 into 20. Because this value is known. If it is 0, in previous case, this value was 0. So we have eliminated or we neglected this term. But here the value of U3 is given. It is equal to 20. So it will become minus 100 into 20. Minus 100 into 20. Now from this equation you will get 200 U2 is equal to 20,000. Okay. So in this way you will get U2. U2 is equal to 200 by, which is nothing but equal to 200 by 100. Okay, so U2 will become 100 mm. Okay, so 0 is equal to 200 times U2, 200 times U2 minus 100 times 20 mm, minus 100 times 20 mm. So in this way, 200 times U2 is equal to 100 into 20. Sorry. 100 into 20 is 2000 actually. Sorry, the mistake here is that 100 into 20 is 2000. So it will become, instead of 2000, 20 divided by 20 divided by 2, it will become 10. So finally you will get the value of U2. U2 is equal to 10 mm. Okay. Now, so the value of U2 is known now. Now, next step is what? Find out the reactions R1 and the force value F. Okay. So, as we know, the value of U2 means, now here we know the value of U1. U2 is also known now, 10 mm, and U3 is known equal to 20 mm. Okay, so from this now we need to find out the R1. So to find out the R1, this can be calculated by using the first equation. So first equation is what? R1 is equal to 100 times 0, 100 into 0, minus 100 times U, minus 100 into, now U2 is nothing but 10, plus 0 times this 20, actually it is 0. So it will become R1 is equal to, this is nothing but 0, minus 100 into 10. So finally R1 will become minus 1000 Newton. So this is your R1. Okay. So how we have found out this R1? So take the equation 1 first or find out this R1. So R1 will become 100 into 0, 0, minus 100 into U2. As we know that the value of U2 is known now because we have found out this value. U2 is equal to 100. So minus 100 into 10, it will become minus 1000 Newton. Similar way, now to find out the value of F, similarly we can apply. So here you will get R1 equal to minus 1000 Newton. Now the value of U3. So to find out the value of F, write down this equation. F is equal to 0 times 0 means 0, minus 100 times U, 100 into U2, U2 is nothing but 10, plus 100 times 20. Okay, so in this way you will get the force value. F is equal to minus 1000 plus 2000. So this will become F finally equal to 1000. So in this way you will get the value of F equal to 1000. Okay, so in this way you can find out the value of F. So okay, now cross check whether these values are correct or incorrect. Okay, so to cross check, if the value of 1000 is applying in tensile direction, in positive direction, then there must be the same magnitude must be at node 1 to balance this spin system. So look, the value of R1 is minus 1000, means it is acting in opposite direction to the force F. Okay, minus 1000. So minus means it is acting in negative direction to that force F is equal to 1000. So our answers are correct now. Okay, so in this way you can cross check your answers also. Means as there is only one force which is acting at node 3. So if this force is acting in right direction or in positive direction or in tensile direction, then there must be the same magnitude of force must be acting in opposite direction at node 1. Okay, and at node 1, why it is node 1? Because this is the reaction, and at node 2 it is not mentioned here. So as we have assumed the F2 is equal to 0, so it must act at node 1, and this is nothing but your reactions. R1 is equal to 1000 Newton. So in this way you can cross check your answers also. Okay, so in this way we calculated our displacement u2 is equal to 10 mm, then reactions R1 at support 1 or at node 1 is equal to 1000 minus 1000 Newton, and force value F is equal to 1000 Newton. So in this way you can find out the displacement as well as force values. Okay. Now let us see the next example. Try to solve this example at home. This is your homework. Suppose try to solve this example at your home, and if you have any problem, then or if you have any doubts regarding this problem, then you can contact me. Okay. So this is the problem. Okay. Now we will take another example. This is your homework. Okay, this is the example. In this example, in this spring system, they have given the spring constant K1 is equal to 200. This K is equal to 400. This K is equal to 200. This K is equal to 400. This K is equal to 600, and this K is equal to 800. And this K 1. Okay. As well as they have mentioned the nodes also. 1. This is 2. This is 3, and this is 4. Okay. So this is the example, and they have asked to find out the nodal displacements and the reactions at support. Also, the value of force is given at this node. At this node, the force value is given equal to 10 kilometers. Okay. So here the value of force is given equal to 10 kilonewton. And the question is what? First thing is what? Find out nodal displacements at node 2 and 3. Okay. Find out the nodal displacement at node 2 and 3. Also find out the reactions at node 1 and 4. Okay, so this is the example. Actually, this example also asked for 8 marks in your same exam. Okay, so this is the example. Now I will just simplify. I will just tell you how to construct the global stiffness matrix or global stiffness matrix, what will be the order for that global stiffness matrix. Okay, so as there are 4 nodes, as in example they have mentioned the nodes also. So there are 4 nodes, 1, 2, 3 and 4. Okay, now between node 1 and node 2 there is one spring. Between node 2 and node 3 there are 3 springs which are connected in parallel. So first one is of value 400, second one is 600, third one is 800. So first simplify this one. Okay, means convert this parallel system into series system. So So to convert this parallel system to series system, you need to add all these values of this key, means 400 plus 600 plus 800, means 400 plus 600 1000, 1000 plus 800 1800. So the equivalent spring constant between node 2 and node 3 will become equal to 1800. Okay, so between first and second node, the spring of magnitude 200 lies. Between node 2 and 3, now the spring of equivalent spring constant k is equal to 1800 will be there, and for between third and fourth node, there is a spring with spring constant 1000 Newton per meter. Okay, so it will become a 3 spring element system now. Means this is first one, this is second one, and this is third one. So for these 3 spring systems, there are 4 nodes: 1, 2, 3, and 4. Okay. So first, you need to construct the elemental stiffness matrices, as we are considering or we are converting this real life problem into a 3 element spring system, means first, second, and third. So for this, you need to construct first 3 elemental stiffness matrices. For this spring system, k is equal to 200, for this spring system k is equal to 1800, and for this spring system k is equal to 1000. Okay, so first you will get the 3 elemental stiffness matrices. Now next is what? Construct the global stiffness matrix. Now the order of global stiffness matrix will be equal to the number of nodes in the spring system. Okay, now number of nodes, how many number of nodes in the spring system? As there are 4 number of nodes, which are there are 4 numbers of nodes for this spring system. So your global stiffness matrix order will become equal to 4 by 4. So global stiffness matrix is constructed by using these elemental stiffness matrices. Okay. Now then next is what? Then apply the boundary conditions, or before that you need to write down these global stiffness matrix into your force and displacement relationship. Okay. So as there are 4 nodes, means the global stiffness, by using this global stiffness matrix you will get 4 equations. Okay. Then next step is what? Apply the boundary conditions. First you need to apply the boundary conditions for nodal forces. Okay. Now at node 1 the reaction is unknown, so it will become R1. At node 2 the force value is given equal to 10 kilonewton. Okay, means 10,000 Newton is given for this node system or for this second node. At node 3 the value of F it is not given, so you can consider it equal to 0, or you can assume it is equal to 0. Then next, at node 4, at this node is fixed one, means the reaction will occur at this node 4. So it will become R1. So R1 10,000 kilonewton, 0 R1. This is your boundary condition for force vector. Now next is what? Boundary condition for your displacement vector. Now displacement vector at this node 1, as this node is fixed one, so displacement will be 0 at this node. So U1 will become 0. Now U2, as U2 it is unknown. This is not fixed one, it is unknown. It will displace by some amount due to this force 10 kilonewton. So U2 is unknown even. Similarly U3 is also unknown even. And now U4. For U4, this node is 1. This node actually is fixed one. So at this node there will not the displacement will not be occurring at this node. So the U4 value will become 0. So your displacement vector boundary condition will become 0, U2, U3 and 0. So in this way you can apply the boundary conditions. Now by applying the boundary conditions, you will come to know which row and which column need to be eliminated. So I will tell you which row and which column it will be will get eliminated. That as we know that U1 is equal to 0, U4 is equal to 0, means at right hand side you will get the displacement value for U1 and U4 is equal to 0. So those displacements are 0. Eliminate those rows and columns. Means first U1 is equal to 0, so eliminate first row, first column. Similarly, U4 is equal to 0, eliminate fourth column, fourth row. So in this way you will get only 2 equations remaining. So by using these 2 equations you can find out the values for U2 and U3. So in this way you will get the U2 and U3, and and then by using the force equations or reactions equations, you will get the reactions at node 1 and at node 4. Okay, so this is the procedure to solve the spring system problems. Okay, so now we will conclude our lecture here. So try to solve this example at your home. If you have any doubt, you can contact me, or you just put the message in WhatsApp group also. Okay, so here we will conclude our lecture. Thank you.